We are now going to discuss a different type of inferential statistics called hypothesis testing. And as you heard me just say, this is inferential statistics, meaning that we are going to use sample data to make a generalization about the population. But before we begin with terminology, let's explore what the idea behind hypothesis testing is. So, what if we want to know whether or not our friend is cheating? So our friend wants to play a simple coin flipping game. If the coin comes up heads, we win. If it comes up tails, our friend wins. So suppose the outcome of 5 plays of the game is tails, 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 tails. In other words, all 5 flips come up tails. Is our friend cheating, or is our friend just really lucky? So to decide that, we're going to determine the likelihood of obtaining 5 tails in a row. So if we assume that the coin is fair, then the probability of getting a tail is the same as the probability of getting a head, which is 1/2. And we know that the flips of the coin are independent. So we want to determine whether or not it is unusual to obtain 5 tails in a row with a fair coin. So how do we do that? Well, first we determine the probability of getting 5 tails in a row, assuming that the coin is fair. So the probability of 5 tails is the probability of tail and tail and tail and tail and tail. And if you recall from way back in chapter 5, and means multiply, so we have the probability of tail times the probability of tail, 5 of them, right? Which is 1/2 times 1/2 times 1/2 times 1/2 times 1/2, or 1/2 to the 5th power, which equals 0.03125. So, if we flipped a fair coin 5 times, 100 different times, meaning 100 trials, we would expect about 3 out of those 100 trials to result in all tails. So it's possible, but it's not likely. Remember, we use the cutoff for unusual if the probability is when the probability is less than 0.05, which 0.03 is. So we can conclude one of 2 things. Either our friend is just lucky, or our friend is not using a fair coin and is cheating. So how do we know which option that really is? Whether it's our friend's lucky or whether they're actually cheating. So this is the idea behind hypothesis testing, is how do we know which one is really happening? So we make an assumption about reality. In this case, the probability of obtaining a tail is 1/2. That's what we have assumed. Then we look at sample evidence, or we gather it and look at it to determine whether or not the sample evidence contradicts our assumption. So how do we go about the process of hypothesis testing? Well, first, I guess we better have some terminology and definitions. So a hypothesis is a statement regarding a characteristic of one or more populations. So in this chapter, we're going to look at hypotheses regarding a single population parameter. And in section 10.1, they may ask us to write hypotheses about the population mean, the population standard deviation, or the population proportion. But in section 10.2, we're going to look at population proportions, and in section 10.3, it will be population means. We are not going to cover how to do hypothesis testing on the standard deviation. So, what kind of examples do we have? According to a Gallup poll conducted in 2008, 80% of Americans felt satisfied with the way things were going in their personal lives. A researcher wonders if the percentage of satisfied Americans is different today. So the key word here is percentage. Remember, percentage and proportion are really the same thing. So this is a statement about a population proportion. Okay, let's look at the second example. The packaging on a light bulb states that the bulb will last 500 hours under normal use. A consumer advocate would like to know if the mean lifetime of a bulb is actually less than 500 hours. So the key word here is mean. So this is a statement about a population mean. So what is the procedure for hypothesis testing? We will pick that up in the next video.